Hi everybody, in this video I want to show you how you can create a REST API with FastAPI. FastAPI is an easy to use framework which allows you to create an API fast, but it is also extensible to build complex and production ready services. In this video we will create a simple to-do API and learn the most important concepts of this fantastic framework. Okay, I'm here in VS Code. You can also use PyCharm or any other editor of course, and before we can start using FastAPI, we of course have to install the package because it is a third-party package, and we do this with pip install and then FastAPI. And we also need UVIcorn, which will be the web server which will run our application. So we just run that and install our dependencies. Okay, now we can start coding. I have already created an app.py, and here is the file where we will write our code. Okay, first we have to import the FastAPI class. So from FastAPI, from the package, we have to import the FastAPI class, and then we have to instantiate this class. To create an endpoint, we can use the add symbol, a so-called decorator, and now we can define what kind of endpoint we want. We can use the get method here for a get endpoint, or post or put or delete, whatever we want. I will first create a little post endpoint. And now we have to define the route. This is the root route, so the index route of a website, and I will just call it hello. And now we have to define a function. We can use a synchronous function, or we can use the async function, which is the better option because FastAPI supports async operations, which makes our app more performant. So we write our function name, just call it hello. And here we can define parameters. Currently we don't use one. I will show you how to use them later. And here we can do whatever we want. We can just return hello. So, and now we have to run our app. We do this by running uvicorn and then app, which is the file, and then double points and the name of the app instance. If we call this our app, we would have to write our app here. So because I just called it app and I will leave it this way, we just run it like this, and then we need a host. We can just do it like this. So it's running on localhost and a port, for example 5566, and then we also have the option to reload the server automatically. So we can develop our code, and if the FastAPI server detects a change in our code, it will restart the code so we don't have to stop our application and start it manually. And now we can see everything is working, and we can visit the URL on HTTP and then localhost on port 5566. So we will just visit our application here, just click on that, and then the browser opens, and as you can see, not found because we don't have a root endpoint, but we have an hello endpoint, so we would have to write hello here, and then we could just post something here. But if we want to see our endpoints in general, we can use the docs endpoint, and here we can see the Swagger UI or OpenAPI UI, and here we see all of our endpoints. We can just click here on this dropdown and click on try it out, and then we can just send our request. We don't have any parameters here because our endpoint just returns hello world. And here we can see hello, even not hello world, but just hello. Okay, this works fine. And from here on, we will create a more complex API where we can define to-dos and add them, update them and delete them and get them. So we build a whole CRUD application from here. To create a to-do here, we will just first create a list of all our to-dos. Just call this to-dos. And now we want to change the endpoints here too, and just call it here to-dos, and this function also add to-dos. And now what we're going to do is every time we make a post request, we want to add an item to this list. We can just do this with passing a parameter here and take data which we passed here and append this to the list. So we're gonna do to-dos.append, and then we append the data, and at the end we just return Here we just gonna return the data. And now if we visit our UI, we should be able to just add the to-do here. And here we can see our data. So we can just type anything here. And yeah, it works. This is our to-do and it gets appended to the list. So what might be the problem with this approach? Currently in the UI, you can just add a string to our to-do list, and this is not the problem itself, but we could also post a dictionary or a number or whatever we want. And normally when you make a post request, the data gets written inside a database and the database expects a specific structure of the data. And currently we have no data validation, so this might cause the database to crash or not work as expected. So we should normally in FastAPI use data validation before we make a post request to our endpoint. And this can be achieved with a custom model, and we have to define our model ourselves to actually define how a to-do should look like. And this is what we're gonna do now. So we will just stop that again. And every time we save here, our to-dos get resetted to nothing because we restart the server every time, and we don't have persistence here because it's just in so-called in-memory database. Let's call it like this at least. And what we're going to do now is we will create our model, which will define how our to-dos look like. And we use a library called Pydantic, and the Pydantic library gets installed as a dependency with FastAPI. So we import from Pydantic, we import the base model. And the base model is a class which we use to inherit from and to create our own model. So what we're gonna do here is create a new class, and we just call it to-do. This class inherits from base model, and here we have to define our fields, for example, the task. And this looks like a data class and works the exact same way, and even puts validation on top. So we can define with type annotation what kind of task should that be. For example, a task is normally a string, but we can also type int if we want a number here. So we'll just use a string currently now. So, and we can also say, should the task be completed or not? So we can say is completed, and this is a Boolean. And we can also set a default value. If we type equals here and then set the value, we can just set it to false. So every time we create our to-do, the to-do will be initiated with a false value. And let's say we also want to create an ID because we want to know how many to-dos we have. So every to-do should have a unique ID, and we can just set it to int here. But what we can also do, if normally databases will handle the IDs, so this is what we're going to mimic here now. We can use type hinting, and we import from typing the optional class. So we can set this ID to an optional parameter, and we can do it like this, and just set it to an optional integer and set it to a default value of none. Okay, so, and this class we can now use in our endpoint here, and we just have to type it like this. So we just call it to-do and then make a type annotation with this to-do class. And now we append this to-do, and at the end we will just return it. And if we visit our UI again, just refresh it here, then we can see now our data looks like this in the request body, and we can define an ID and a task. And here we gonna see that this is currently false. We can also set it to true. And so if we click execute, we can see in the response body, this is the new to-do with an ID of 0, the task of string, and is completed of false. But if we set this, for example, to some kind of string, here is where type validation happens. And we can see, here we can see our 4-to-2 code. So this is called an unprocessable entity. So as we can see, here is the message, value is not a valid integer. So this is where the validation happens and we won't actually add a to-do with a wrong type here. So we can just use integers here, and this will be validated by Pydantic and make our API more safe. Okay, with this knowledge, we can create our quad application. So first we're gonna create the to-dos, and we make this a little bit more dynamic because we want the ID to be based on the length of this list. So what we're gonna do here is we set the to-do ID, which is a property here. We can access it with just a point and then the ID, and set this to the length of the to-dos list plus 1. So if the list is empty, we will create an ID with a number of 1. And then we will just add this here and everything works as intended. So we will just create our second endpoint now and make this a get request where we will just get our to-dos. We can also call it to-dos. And because we make our different requests, here we make a post, here we make a get, it's possible to call it the same here. And we will just call this get or read to-dos. And here we need no parameter. We will just return the whole to-do list. And as you can see, now we've got a second drop down here. Let's add a first to-do here. This was optional, so we don't have to use it. And as you can see, this works and we get an ID of 1. We can just do it again and see we get an ID of 2. So this works fine. And now we can use this endpoint and get the whole to-do list. So, okay, here we get our whole to-dos, but what if we want to get a single to-do based on the ID? How could we do that? We have to use a concept called path parameters, and this looks like this. So we first have to write a new endpoint and just make it to-dos again, and then write a second slash, and then use brackets, curly braces here. And this is the path parameter. This is the dynamic part of our URL. This can be a 1, a 2, a 3, or whatever number our to-do should have, we want to retrieve. And we also have to use this ID inside the function as parameter. So like this, read to-do, and we have to call it the same as the path parameter, and then annotate it with the type we want to have. So example, the ID is an integer, so we have to annotate it with an int value. And now we can just use a for loop, for example, for to-do in to-dos. And if the ID of the current to-do in our iteration matches the ID we pass inside the path parameter, we want to return the to-do. Okay, let's try that out. Now we first create a to-do. So we added one and added another one. We have to be careful here with the IDs. Okay, this works now. And let's say we want to get our to-do with the ID of 4. And here we get it. And if we use a 10 here, for example, we get a response body of null. This is okay, but it's even better when we raise a 404 error. So maybe you know that from a website. When there is nothing to view, you normally get a 404 error, which means not found. And we can also implement that here in our REST API. To achieve that, we have to import another class from FastAPI. And this is the HTTP exception class. And we can say if we don't return anything, we can just raise this HTTP exception. And here we have our status code, which will be a 404, so which means not found. And then we write the detail, and the detail is item not found. So if you do this again, we now get a 404, detail item not found. This is better because it's more specific, and this is the way we should implement not found error in our API. Okay, now let's create our put and delete endpoints to update a to-do and to delete a to-do. And this will be pretty easy with the knowledge we already have. So we just make it like this, app.put to update a to-do. And we have to use the to-dos endpoint and pass a path parameter here, because we also have to access a single ID here. And we just call it update to-do. This ID has to be passed again, and it will be an integer. And this is the way we access our to-do. And now we have to update it with a new to-do, and we just call it new to-do. And this will be of the kind to-do. And then we iterate over our to-do list. We won't use a normal for loop here, because we also want to get the index of the to-do. So we're gonna do it like this: for index and to-do in enumerate. Enumerate is a function which allows us to access the item itself and also the index. And we enumerate over the to-do list here. And we're gonna say if the to-do.id equals id, so the same like above. And here we're gonna need the index now, to-dos, and here we get the index. And this will be the new to-do. So for example, if our index is 1, we update the list of where the index is 1 with our new to-do. And just to make it sure, we also update the ID here with the path parameter here, and just update this ID. So after this, we will just say return, because in a put endpoint, we don't return the to-do again. So we just say return and give back a 200 status code, which is the default status code to update a to-do. So if we don't find a to-do here, we just gonna do the exact same thing again, and just raise an HTTP exception with a status code of 404, detail item not found. Okay, now we're gonna make a delete request, add app and delete. And it works again the exact same way. We use a dynamic path parameter here and write it like this: async def and delete to do. And we pass the ID as type integer. And again, we make an enumerate here for index and to do in enumerate. And we gonna enumerate over the to-do list. And if the to-do.id equals the ID, then we want to delete it. We can just do it like this with the del keyword and delete the to-do with the index here. So we need this because we the ID with index 0 will have an ID of 1, so we need the index and the to-do ID itself. Okay, and if everything works as expected, we also just make a return here, and don't return the deleted to-do or whatever, just return and give back the status code to 200. If it didn't work, again, we will just raise our status code. So pretty easy and almost always pretty similar. Okay, let's try that out. Again, just press F5, and now we can see we have two get endpoints and a post endpoint, a put endpoint, and a delete endpoint. Let's just add a new to-do here. Don't give it an ID. Just press it a few times and we can see now we've got 7 to-dos here. We can just get it here with 5, for example. This works. If we use 50, we'll get a not found. So this works fine. And now we want to update a to-do. And let's say we want to update the ID of ID 5. This has to be deleted. And the task will be buying stuff, whatever we want, and just execute it here. And we can see we get a 200 and the response body is null as expected. But if we want to retrieve our to-dos here, we now should see that this to-do with an ID of 5 has now the task of buying stuff. So this works as expected. And now the last step here is to create or delete it. And we just do this again. And response body is null. If we do it again, it should not work because the item was not found. And yeah, that works perfect. Okay, that's it. That is a pretty basic API, and we will now explore a few more concepts to make our apps even better. So the first concept will be a response model. Currently, when we make our request to our to-dos endpoint with a post request here, we pass in a new to-do and we return this to-do. But let's think of a user database where a user enters a password and this password gets evaluated here. We don't want to return this data. So in general, we don't want to return any sensitive data from the API. So the password should be stripped from the output. This is where response models work very nice, and we can just refactor our to-do class here and make a new base to-do model, for example. And this base to-do inherits from base model. And we just want to say that every base to-do only has got a task. And this is our base to-do. And now our new to-do can inherit from this base to-do. So if we want to create a new to-do, this will have the field from the base to-do and also the fields which we will define here. So, but if we want to return something, let's call it return to-do. And we also inherit here from base to-do. We just want to return not the is completed and also not the ID. So we can just say pass here. Okay, now we have to use it, and we're going to use it here in our post endpoint and just write response model, and our response model will be return to do. Okay, if we take a look at the UI, press F5 here, and we can now see the task is string, the ID is 0. We can just remove it like this. And if we run our request here, we can see that in our response body, it only contains the task, but not the Boolean here, if it is completed or not. This was stripped out from the model. So this is an easy and fast way to strip out data we don't want to output from our API. The next concept we're taking a look at are query parameters. If you have ever seen a website, for example, like localhost and to-dos, and then a slash, a question mark, a name, and an equals, and then some random number, for example, this is a query parameter, and this makes our API even more dynamic. For example, in our to-do list, we might want to retrieve only the first 10 to-dos, or maybe only the completed to-dos. And this is where query parameters comes in handy and make our app even more dynamic. To do this, we have to pass a parameter here inside our function, and we just call it completed. And this will be an optional parameter because we don't want to be forced to use these kind of query parameters. And we make it an optional bool and set it to a default value of none. So if completed is none, we want to return just the to-dos. And otherwise, we write an else here, we just gonna retrieve the to-dos. So we're just gonna write a list comprehension here, to do for to do in to-dos. And then here we write the condition, if to do is completed equals completed. So we can set it to true and to false here. And if it's none, we're just gonna retrieve every to do. So we're gonna remove this. And now if we take a look inside our URL, I'm just gonna first post a new to do here, or a few. So let's add some to dos. And now we can just get all of our to dos. This works fine. And if we set it to true here, so with true we get an empty list, and here we can see the requested URL. This is our endpoint here with the to-dos, and then there's the question mark, and then completed, and we set it to true. And this is the request URL, and we make our GET request to this URL with this query parameters here. So this is very helpful to make our apps even more flexible. The next and a little bit more advanced concept is middleware. Middleware components are executed for each request before the request reaches the route function. So this is the route function, and also before the response is returned. What this exactly means, I will show you in the code. It makes it easier to explain. And to write middleware, we have to use a decorator and then middleware. And inside this middleware function, we have to define what kind of middleware we want to use, and we want to use an HTTP middleware. So now we have to define our function, and we will call it log requests because we want to measure the time a request takes in our API route. But I will first show you how it works in general. So we just call it log middleware, and the first parameter here is a request, and the second is a function which is called call next. And the call next function is a function that you call within your middleware to proceed to the next middleware inside the chain. So for example, we do something before the route, and then we call the call next function, and this will pass the request to the actual API route. So what we're going to do now is this. So call next, and we will pass the request to this call next function. And this will create the response from the API, and we can do now something afterwards. For example, just call it after route, and then just return the response from this function. So we're gonna make this a little bit more useful, and we will import from time, import time, and then we will just define a start time here. Start time equals time, and then the request is being done, and now we will run this function a second time. So we'll call this end time, and this is also just a function call, and then we calculate our process time, and this is end time minus start time. And then we can just print with an F string, for example, request, and then we've got from the request object, we've got an URL field, and we can just write processed in, and then the process time in seconds. Okay, I will just remove this print statement and this. And if we make a request now, we will see, if we make our GET request here, okay, we've got an error here because we've got an async function and we have to await this here because otherwise it will not work. And if you run it again, now we should see it in our logs, and we can see request, and here is our URL, processed in 0.0 seconds. Just remove that. So this works, and we have our middleware for every URL. We use it here on the GET request. We can also use it here for the POST request, and it should work out of the box, and we should see every request logged in our terminal. You don't have to write all of your middleware by yourself. FastAPI already provides the middleware, and the most popular and maybe most important middleware is Course middleware. Course middleware allows you to define from which origins you allow requests to your API, and if you want to allow headers and special methods in your API. We can just import this from FastAPI.middleware.course, import the course middleware class. And after instantiating the app here, we can use the app and then add middleware method. And here we can add our middleware class. We can see this is the type. And then we can use another keyword arguments here. And these will be our origins. So these have to be called allow origins. And to allow requests from every other website, we can just use a wildcard operator here. This is what we're gonna do now. And we can use allow credentials here to allow requests with credentials. And we can say we allow special methods with allow methods, and we also use a list here. We could just use post or get or whatever, and we can also use a wildcard operator to allow every method from the other website. And we can also use allow headers, and this we make also wildcard, so we allow all headers in the request header to be able to be posted to our API. So a use case for this is, for example, if you have a front end and the backend is your API, and you don't want to allow any other user than yourself to access this API. So you would just write, for example, your website.com, and now only your website is allowed to make a request to this API, and so it's more secure to use this course middleware here. If you want it public, then just write a wildcard. The last concept I want to show you is the background task. Let's say you have a long-running task. Let's say it's a function which runs for 10 seconds inside this endpoint, and the problem is that the user will get a response after that function is run through, and this blocks the API and makes the user experience very slow. The solution is to run that function in a separate process, and this is what background tasks are for. So this long-running task won't block the API. I'm gonna show you how to do this. Let's say we have a function, let's call it send email, and this takes the to-do as input here, and we just print email notification for to-do.id send. Okay, this is the function we want to run in our background, even though it's not a long-running function, but it could be. So to do this, we have to import from FastAPI the background tasks class. So now we have to go to our endpoint, and we will use it in the post endpoint here as a second parameter. And here inside the function, we just have to call it background task, and here we annotate it with the background tasks. So, and here we just say background task dot add task, and with this method we add a function to a separate thread, and we want to add this email function here to this task, and this takes one parameter, and this is the to do, which we pass inside the API function body, and then this function will be executed separately from returning this to do. So this can take 10 seconds and still won't block that to do from being returned. So if your API is slow for some endpoints, maybe think about running some task in the background. But you also have to be careful. This task here is independent from this to-do value. So if you want to calculate and store it, let's say in a result variable, and then return it here, this is definitely not a good use case for this background task. So only run it if this function runs independent from the output you want to return. Okay, and that's it for this introduction. I hope you learned a lot and can see why FastAPI is liked by the community so much. If you liked the video, feel free to subscribe to my channel and like the video, of course. See you, bye bye.